Hi, I'm Craig Grant. Today we're going to go further down the untrodden path, and I'm going to show you how to factorise and expand cubics using the polynomial pattern, and it's very, very easy. Thank you. Now I'll start by giving you the big picture. Here's the polynomial pattern here. It's related to simple quadratics and simple cubics. It's also related to complex quadratics and complex cubics. Here's Pascal's triangle. The first row is 1, the second row is 1 and 1. The third row is 1, 2, 1. Now look at the pattern. This is the pattern. Let's have a look again. 1 and 1 make 2. There. The next one, it's 1, 3, 3, 1. 1 and 2 make 3 there. 1 and 2 and 1 make 3 there. The next line, 1 and 3 make 4, 3 and 3 make 6, 3 and 1 make 4, and that's 1. If you went down 1 further, there'd be a 1 there, a 5 there. What would be there? There'd be a 10 there. What would be here? A 10, a 5, and then a 1. Pascal's triangle shows up in a lot of places, so it's a handy thing to know. Now I've got to be careful with the positioning because it's fairly way down. Now let's look in here and I'll show you Pascal's triangle. It's the second row of Pascal's triangle, 1 and 1. The third row, 1, 2, 1. The third row, 1, 3, 3, 1. And the fourth row, when we do an expansion of a quartic, is 1, 4, 6, 4, 1. You see there's one element there and one element there. In here we have two elements. In here we have 1, 2, 3 elements. There's 3 elements there. What happens with quadratics? Simple quadratics, you've got two numbers that add together, the sum, have a sum, which is the number in front of x. And the product, when you multiply them together, is the number on the end. For cubics, you have a sum of 3 numbers, which is the number in front of x. And then the number on the end is the 3 numbers multiplied together. So this is what I call the combinations of 1, the combinations of 2. Here's the combinations of 1. If we extend the pattern, that's the combinations of 1, that's the combinations of 2, that's the combinations of 3, and that's the combinations of 4. This one here, all I do is I leave out A, and I go B, C, D, there. I leave out B, and it's A, C, D. Then I leave out C, and it's A, B, D. Then I leave out D, and it's A, B, C. Anyway, let's get on to the expanding of cubics, which is quite interesting and actually very, very easy. Now, I've only done, make sure I get that line up, expanding of cubics, actually that should be simple cubics. If we take this one here, x plus 1, x plus 2, x plus 3, we look at the sum of the 3 numbers, 1 plus 2 plus 3, 1 plus 2 plus 3 is 6. So it's x cubed plus 6x. Then we look at the combinations of 2. We have 1 with 2, there. 1 with 3, and then 2 with 3. There they are there. That'll give us 2, and 3 is 5, and 6 is 11. Then we multiply them together. 1 times 2 times 3 is 6. And there we have it. Now, we will go through one of these. Now, I have adapted the loopy method to make it easier for you to work out. So, what you do is you'll go write down x cubed, then you'll go 2 plus 3 is 5 plus 4 is 9x squared. Then when you want to find the number in front of x, you put the loops in. So you loop from 2 to 3 and 2 to 4, and then 3 to 4. And when I was teaching this to my boys, I would talk about the irrigation race method. Now, This is one side of the irrigation race, that's the other side of the irrigation race, and this is the bottom of the irrigation race. And I'll say to them, there are 6 trout on this side swimming upstream, and there are 8 trout on that side swimming upstream, and there are 12 trout on the bottom. How many trout are there in the irrigation race? And they just add them up. The answer would be 26. 8 and 12 is 20, and 6 is 26. Now the product, all we do is multiply them together. 2 times 3 is 6, times 4 is 24. There she's done. Now, we'll have a look at this next one. We want to look at the number in front of x squared, so what do? See, the number in front of x squared is the 3-number sum. What are the 3 numbers? 3, 4 and 5. What do those numbers add up to? 3 and 4 is 7 and 5 is 12. So the number 12 goes there. Right, now we want to do the combinations of 2. So we go 3 times 4, which is 12. We go 3 times 5, which is 15. And then we go 4 times 5, which is 20. So we add 20, 12 and 15, and we will get 47. There we are. Nice, big, nice and big. And then for the last number we go 3 times 4 is 12, times 5 is 16. There's the expansion. That's all there is to it for simple quadratics. Now we're going to go to factorising cubics. Now remember, the number in front of x is the 3-number sum. The number in front of x squared, and the number in front of x is the loop sum. There are the loops, and the number on the end is the product. But we're going to just focus on the sum and the product, which is what we do with quadratics. There we go. Now I'll get that lined up. We've got to factorise this. X cubed plus 9x squared plus 24x plus 20. So the 3-number sum is 9, we get that from there. The 3-number product is 20. So we just look at the 3-number product. Here it is, first one, and we do it in order. 1 times 1 is 20, 1 times 2 is 10, 1 times 4 is 5. And that one we deal with the ones. Now we try the 2 because that's even. It's 2 times 2 is 4 times 5 is 20, and when we add those up, 2 plus 2 is 4 plus 5 is 9. We've got a match. So we can now reveal the answer. And there's the answer. X plus 2 in the first bracket, x plus 2 in the second, and x plus 5 in the third. Now we just do one more question, a little bit harder. X cubed plus 12x plus 47x plus 60. Looks terrible, doesn't it? Okay, 3-number sum is going to be 12. The 3-number product is 60. And I would suggest that you do it in order, because you can use these numbers down here to work those ones there out. So it's 1 times 1 times 60, 1 times 2 times 30, 1 times 3 times 20, 1 times 5 times 12, and 1 times 6 times 10. And we start at 2. 2 times 2 is 4, times 15 is 60, 2 3s are 6, times 10 is 60, and 3 times 4 is 12, times 5 is 60, and we've got to get a sum of 12. Well, what have we got? 3 and 4 is 7, and 5 is going to be 12. And probably when you're dealing with these big cubics, the number is going to be in this area here, and you probably don't have to worry about the ones, but it's quite handy to use the ones to make sure we don't miss any factors, and we'll flip that over, and there's your answer. X plus 3 in the first bracket, x plus 4 in the second, and x plus 5 in the third. And in the next video, I'll deal with complex cubics where we have negative signs. These are just all positive, so it makes it easy. It's a wee bit trickier, but if you're up for it, it'll be there in the next video. Thank you very much.